Okay, in this class we'll be talking about the references in C++, and also we'll talk about parameter passing techniques, call by value, call by address, and call by reference, and we'll see the differences. So that was outline. Okay, let me connect the WACOM. Just wait for a moment. Okay, can you see the screen now?
Yes, sir.
So we are talking about pointers in general, and we have discussed about the basics of pointers, the use of constants with pointers, the memory layout, dynamic allocation in C++ using the new and delete operators, and we have considered dynamic allocation for 1D and 2-dimensional arrays. And in this class we will be talking about these reference variables, use of reference, and reference versus constants. Okay, and the remaining will be these portions, how we use the reference and pointers in association with structures or classes in general. Okay, so this will be the focus of this class. We'll be talking about reference variables. So reference, this is not this was not available in C, right? So this is entirely a feature of C++, or I mean object-oriented languages. They define this, and C++ is also having this nice feature. So we'll see that why it is advantageous and when we should be using references, and what is the necessity of this. So reference as such, it stands for pseudonym, right? Pseudonym means these are aliases, you can say, the names. Sometimes you can consider it to be a fictitious name that a person or a group assumes for a particular purpose. So in addition to the real name, so these are names generally in real life also. We see that we do have. দিনেশ আমি ক্লাসে ঢুকেছি, তুমি পাঠিয়ে দাও এটা। হ্যাঁ ঠিক আছে, হ্যাঁ ঠিক আছে, ওকে। So what is the purpose? There may be several purposes, like the stage actors, as a stage names the actors uses, the writers they use the pen names, and we do have general public, we do have nicknames. So the hackers, they have the code names like this. So these are all we can categorize as pseudonyms, right? And the objective to what is objective? In many of the cases we would like to remain anonymous. That was the objective, to create pseudonyms like this in a real life. But these pseudonyms, these are basically part-time names, you can say. So pseudonyms does not mean the original name goes off. These are part-time names only to be used in certain contexts, right? So in my case, maybe say, so this is not for anonymity, but maybe in the department I would prefer to be called as SN because I am familiar with that. Students and also sometimes the faculties also call me SN. But to my friends, they call me just Shubroto with my first name, and there may be other names also. And in my residence, I mean within my family, maybe my parents call me with some other name. So this is quite common. So depending on the context, so if somebody uh, within my family calls me SN, so probably I'll be surprised and I'll not be able to, I'll not respond to it. So these pseudonyms are mainly meant for using in a certain context. Similar to this, variables, we know that variables, the name of the variable is very important because that associates So whenever we write int x, that means if I write here equals to 10, so in the memory we have got say 4 bytes allocated and this value of 10 saved, but this block of space is identified with the name x, right? So x is the name given to it, and through that, so that is called variable name because the contents of this block might be changed. If it is a constant, we cannot change it. So if it is constant, we cannot change it. If it is a variable, we can change it, but this block of space is identified by the specific name. And generally in the programming languages, the compilers maintain a symbol table, or you can call it as a name table. So if this is the allocation that has taken place, so if this allocation, the address of this allocation is 2005, so it says 2005, maybe it stores the type of that, it's an integer type block, and its name is sorry, x, right? So this is a name associated, or the id identifier, this is a type, and this is the address. So this is the symbol table. So you can say that this is equivalent to a person. Okay, this block is equivalent to a person. So as in a real life, we can uh, create aliases, we can create nicknames, we can create additional names or pseudonyms, variables. Variables or constants or a particular storage unit in the RAM may like to associate with multiple names. That is possible. Got the point? And that is what is called creating a reference of it. So more like the way we generally try to assign multiple names, pseudonyms, variables or constants, or any specific location which has been allocated on request due to declaration. Till now, we associate a particular storage unit with a single name. It may be a variable name or it may be a constant name. But from now on, we'll see that if requires, so when and how it is required, we'll see that if we want, we can associate multiple names to that particular unit. So just we'll use any name you call, the same person will respond. Here is also any name you use, the same storage location will be accessed. You can modify, you can access, you can read, and whatever you want. Okay. So in programming language, a pseudonym is created by using the feature called reference. Okay. So how many of you have used reference, the reference variable in your codes till now? Anybody who has used it usefully? Hello? Are you getting me? I'm talking to the class. Are you getting me?
Sure.
Yes. How many of you have used references in your codes? Anybody?
So
Nobody
haven't
who
really
has.
used them, sir.
Yes. Yes.
So haven't really used them, sir.
Okay. You have not used it, but do you know that the reference is a particular feature that is available in C++?
Yes, sir. Yes, sir. Yes, sir. Know about it, but haven't really used it in like while doing programs or something like that, sir.
Hmm. Because without knowing reference also, that whatever you are doing, you can do it quite nicely. But if you know references, maybe few things will be easily done. So we'll see that how it is possible, right? So references in C++, so reference is a feature that allows a programmer to provide an, or maybe an additional name or more than one names also to an existing data item. This may be a variable or a constant. So this is important to an existing data item. So the thing is, say you cannot assign a name to a student who does not exist, who has already left. So there is no point of assigning name to that person who is not there in that context. So the first criteria is the storage unit, because we are trying to name a storage unit which we have allocated through the declaration statement, right? So this must exist, and whenever you try to declare, you by default you associate a name with it. So through the references, the thing is you are allowed, or as a programmer you are allowed to provide additional names to it apart from that default name that is there. So generally when say I joined this department, I just had that name, my original name, but then maybe SN is one name that I know that people calls me, I mean the students call me, but maybe there are other names also then, because the faculties they are uh, because based on the attributes or based on their behavioral gestures, features and all, students used to give them additional names also, and many of the names I really don't know what other names are also assigned to me. Okay, so this is possible in our programming also. So if you think of a variable name as a label attached to the variable's location, so if this is say these are the 4 bytes for an integer, say int x equals to 2, so this you can see that this is a tag that you attach with this particular block. This original name label is x, you just attach a label. So reference means you are tagging few more labels to it, and each label means one new name. So once this happens, so you may consider reference to be another label attached to the memory location, and once the memory location is one may access the location either by the original name or its reference, doesn't matter. So if I, so how to do that, this is how we do this. So as you can see here, so this, if I execute this statement, so the first statement I execute, so this allocation is done, the declaration is done, and this allocation is done, and x is the name attached to it up to this. When I execute this one, that means what I'm trying to say here, y is the name, is the name reference, is a new reference. So this means you read this together. So y is a reference to an integer. You are trying to rename a integer variable, or I mean integer entity. What is the entity? This is the entity x. So here you write something that exists, that already exists. So here x exists because you have to, how to specify whom do you want to create a new name, you specify that name, so x. So here it says that y is a new name, it's a reference corresponding to a integer entity. What is the entity? This x is that entity. So if I do this, what does it mean? This third statement, what does it mean? Z is a reference to integer entities. Now who is Z referring to? Z is referring to, hello?
So Z is a pseudonym for X now indirectly because it's also pseudonym for Y now.
Yes. So here I say that Z is a pseudonym for Y, but Y is also a pseudonym for X. So even though you write here this, that means Z is basically a pseudonym for this associated space, right? Which was originally known as Y. Later on, uh, it was not renamed; it was additionally named as Y, and now it will be known as Z also, in addition to X and Y. Is that fine? So this is what is going to happen. So if I write cout xyz, what do you expect here?
Or it would be 222.
It will be 222.
Yes.
All others, do you agree with this? It will be 222. Hello?
Yes, sir. Yes,
Yes,
sir.
because it will be the, so it doesn't matter who the person is. I mean, if I am the person, if somebody calls me SN, somebody calls me with my first name, somebody calls me with maybe with my surname, or maybe some other names that I don't even know. So maybe I'll be the same person responding. So here, now you say that what's the point of creating so many names, because anyway you are not allocating space or you are doing nothing. So what is the point of creating so many names for a particular person? So we'll see that how it is required sometimes. Okay, so let us for the time being assume that this is possible, right? Now if I write y plus plus, this, then what is going, if I write y plus plus, I'm trying to increment the location which is labeled by y, or which is identified as y, right? So this is the location. So from 2 it becomes 3. So once it becomes 3, if I write C out XYZ, what is going to happen? What will be displayed here? 333, right? Because so the thing is, it doesn't matter through whom you are updating. So you are updating y plus plus means you are basically updating, you can say x also, y also, z also, because they are all referring to the same storage unit or same entity. Fine. So last, I mean, in this example, what we have done, the original name was x. Now we have created multiple references to it. So here one can create multiple references. One can create multiple references to an existing variable or constant, doesn't matter, existing entity. So this is possible, we just now found it. One can create reference to a particular type. So when you are trying to create a reference, say this is y, you cannot just write y. So if it is int x equals to 2, so if I just write this, will it work?
No, sir.
No,
This
sir.
means when you are trying to create a reference, so this means you are trying to create a reference, you should specify what type of entity you are trying to create a new reference. So you have to write here int, okay, a particular type. So type should be mentioned here, whatever is the type, whatever the type is. And another important point is, so if I write here int y ampersand x, what does it mean? Sorry, I mean, uh, or if I write here ampersand x here, what does it mean?
So address of X.
Address of x. But when I'm using the ampersand symbol during the declaration in the left hand side, this becomes a declaration of reference. See, the same symbol I am using here to obtain the address, but here when I'm using in this side, so this is the L value and these are value. It's the left side value and the right side value of the assignment. So if you're using the left L value in a suitable way, then that means I'm trying to create a new name to some existing ones. Here x should have existed, right? But here when I'm using it in the R value, okay, in the right hand side, that means I'm trying to get the address of it. So we should know that the same symbol is used to either create a new reference or to sometimes it is for getting the address of it. So it might be confusing in the initial stage, but once you know that, uh, then you can differentiate it. So a reference must be initialized when declared. This is very important. If I write something like this in z, what does it mean? What may be the meaning of this? Z is a reference to an integer entity, right? To whom? So you say that I created a name, but people will say that I created. So you say that I created a name for faculty, for some faculty like that. So what is the name? This is the name. Does it really matter? Because does it really make sense? Because when you are creating a name, you should say that whom you are trying to refer to that name. Otherwise, it does not make sense. So whenever we create a reference, it must be initialized, or you must say that Z is a reference to integer entities, and Z should be referring to, or Z should be a label for this particular storage. So that should be clear. So this is not allowed uninitialized. You have to initialize it here, because there is no point of just creating a set of names without explicitly telling that who they are actually referring to, which particular storage location they are actually referring to, right? So once reference name is assigned, it cannot be used by others. So see the point. Okay, let me, the eraser is not working here. So if I write here int asterisk, got this? So this is the first statement, this is the second statement, and again I am writing and there is int say p equals to 10. So there is one integer variable, there is another integer variable, and this is a reference or a name y which I would like to refer to with the existing variable x. Once it is done, if I again write y p, will that be allowed? Will that be allowed?
No, sir.
So it's something like
No, sir.
in the first 2 years, I mean first year or first 2 semesters, you started calling say some with some name, some physics faculty or some chemistry faculty or whatever. Okay. Now you find that the similar attributes are found in me also, and you say that okay, I'll use the same name to this person. So generally that never happens, right? Because the name is so much tied up with that particular person, so generally we don't use the same names, and this is here also it is not possible. So if you really like to give me a assign a new name to me based on my characteristics and features, you should use a different name. So maybe Z here. So once you have used a name, you cannot use the name in the same context or in the same scope or in the same code, whatever, right? So creating a reference, so the reference name once assigned cannot be used by others. And creating reference does not create additional space. So this is very important because we already have found that creating reference will not, so it's not declaration. It is basically assigning a new name to it. That's all. So XYZ, just once it has been allocated when the first time X was assigned to it, the label X, but for X and Y, Z and Y, there was no additional space allocated. That is something strange because any declaration till now will either seek some space from the stack segment or from the heap segment or from the data segment, something like that. But these reference variables are not meant for declaring I mean allocating a new space and assigning name to it. They are only meant for uh, adding new names to existing ones, so there is no additional space that gets allocated. Got this point up to this? Hello? So reference null
Yes.
references are not, so null references are not possible. What are null references? So like pointers, we know that if I declared a pointer say int asterisk p, then I can assign int asterisk p, I can assign null to it. But we know that in case of reference, you say that okay, let me try this xyz, maybe v, I can assign null, but this is not possible. So references must be initialized or must be assigned to existing entity, to some entity that already exists, and that must be done. So you cannot neither you can leave it like this, okay, without assigning, without initialization, nor you can assign to null also. So this also does not make sense because it is after all naming some existing entity. So you should be very much clear and explicit about whom you are trying to refer to. Okay, so null references are not possible. And dynamic allocation of a reference is also not possible. Does it make sense? Dynamic allocation of references?
No, sir.
Because just now we mentioned that it does not create any additional space. So this definitely is not possible or does not make sense. These are absurd. And creating an array of references is also not possible. Okay, so this is what I mean. So this what I mean, this A10. So you see, so for every name, so whenever you assign names, so whenever some twins are born, so you cannot just say that okay, I've got an array of names. So names are just like explicit, and specifically it should be tagged to the entity. So whenever twins are born also, so each twin, each of them, they should be individually named, right? So here also the same thing. You cannot really say that it's a bunch of names. That does not make sense. So this array of references, this is also absurd. So here I try to create, but it is not possible. So here I try to say probably this A is a reference array of, I mean, it's a it's an array of 10 references. So that does not really make sense. So this is not possible. And then array of references. So in this way also you say that, okay, I am not initialized. If I force it to initialize, that also will not work. Okay. So these are not possible. So null reference is not possible. Dynamic allocation of reference does not make sense. Creating an array of references is also not possible. So if I try to find out the differences between references and pointers. So what are the differences? Pointers, constants or variables are explicit entities which store the address of other entities. So if this is a pointer, int asterisk p storing the address of A, and if this is int reference say q, so p is a pointer to A and q is a reference to A. So if I look into the allocation, memory allocation, so A means it will take 4 bytes. So this is A. So P is a pointer variable, right? And P is a pointer variable means it will require some space by itself also. So P also requires some space. And P is pointing to A. But Q is just like another name for A. Q, A or Q. Got it? So this is identified by A or Q. And P is pointing to it. So these two are not the same. So we can have null references, but we cannot have null references, but we can always assign null to the pointers. Once a reference is initialized to an object, it cannot be changed to other objects. So references are like constant pointers. Once you fix it to a particular address, it's pointing to a particular address. You cannot change it once again. So references in that sense, it is something similar to pointer constants, not pointer variables, because you cannot also change them. And references must be initialized, but pointers, if it is a variable, pointers can be initialized at any time, or it can be assigned or changed values. If it is a variable, it's specifically, let's say, pointer variables. If it's a pointer constant, then it is not possible. Okay. So now let us see this example. Let us focus here, right? What I did. So up to this, is it clear? It is. So we have not talked about something very difficult or something very complicated. So just we talked about one more feature, that is reference type. So this is int x equals to 5. Then what I do here, here, and here, I have created. What is the purpose of these 3 lines?
References.
Reference.
How many references I have created for x here?
So three, like three, one direct reference and two indirect references. Sorry,
Yeah,
two direct references.
basically 3 references. One to the direct level. So if you note that, so now after this statement, how many names through how many names we can recognize the storage of x?
4.
Okay. So after this step, it will be recognized by 4 names, right? So if I display this statement, set w6, so I give some space, initial blanks, then x, r1x, r2x, r3x. So it will be displaying the same value. So we see here it will be all 5. Don't I? So if I write here r2x plus plus, so whichever name you call the location, okay, just a minute. It's a problem. Okay, so here, so it is 555. Now if I increment it by 1, no matter through which name you increment it, but you are making change in that entity, right? And that should be reflected through whichever name you call it once again. So it will be all all of these will display 6, because you are basically, this means through some of its name, some of its level, you are trying to modify the contents of it. That's all. So here it's a one dimensional integer of size 4. So what I'm trying to do here in this line, what is the purpose of this line?
Start creating a reference for this third element in array A1.
Yes. So this is a third element, right? So there is an array of integers. So I would like to call the third element of the array by some specific name. That is A3 here, right? So I would like to call it as A3. So how to do that? So I just specified that A1, 2, that means the third element, and I've created, it's a basically integer element. So that's why I did that A3 is a reference to an integer. And so once I have done this, so in the memory, you've got allocation for all these 4, right? So it stores 2, then 4, then 6, then 8. So this is already existing, right? The whole array, all the elements are existing. Now you say that I would like to refer to this element as A3. Okay, this is the name that I tag it. It's not a pointer, it's a name that I give. Generally, array elements are not called by specific names because they are identified, or they're basically known by the array name itself, right? But here I would prefer to call the third element of the array specifically by a given name. And what I do here, so this is a simple one. A1 is, so what is this? Is this a correct statement? What do I write? Int asterisk p equals A1. What does it mean? What is the purpose? Can you see this? What is the purpose?
अब decide करो.
Hmm? What I'm trying to do here?
The pointer to the first element of the array.
Yes, pointer to the first element. In turn, I mean, if you know the first element's array address, then you can access to the all the elements of the array. So it's basically assigning the base address of the array. And what I've done here in this second statement, I'm
So
creating a reference
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 to
of
the address of the first element.
reference to p, reference to the pointer variable. So I'm not concerned about what p was pointing to. P might point to null also. I don't care. So here this statement is meant for what? It's meant for creating a new name for the pointer variable p, right? So this q and p both are referring to. So in this case, if this is say p, which was pointing to this base address of the array. So now p or q. So this pointer variable after this statement may be called as p, it was original name, or to its pseudonym or reference q. That is what it means, right? Here,
Yes, sir.
we have created a reference to the pointer variable. Doesn't matter whether it is storing the address of the one dimensional array A1 or something else, I don't care. But that was the purpose of it. And definitely based on the last value that p contained, so both p and q, whatever name you use, if you write asterisk p or asterisk q, you basically go to the you basically access the 0th element of that array. So what values will be displayed here? A1, 2. A1, 2 means it is 6, right? Then I write A3. What is A3? A3 is a reference to that. So it's just a name given to it. So what A1, 2 stores or displays, A3 also displays the same thing because it's just a new name that we have given to it. Then I write here P2. P2 is what? So P2 means this is the through the pointer you are trying to access. So P2 means P plus 2 whole of asterisk. So this is also 6. And if I write here Q2, then also it will be the same, right? If I write here Q2, then also you would have got a 6 here. Okay, because now both P and Q, I mean this pointer is known by both P and Q. What about this one? So this is a 2D array of 2 rows and 3 columns, and what I'm trying to do here, the 0 1th element of that 2D array, 0 1th, so that means this 2, I'm trying to give a new name to this particular element, and I would like to call it as B2. It is just an integer type, so it is integer. It's a B2 is a reference to an integer element, and it has the name has been assigned to the 0 1th element of this 2D array, right? Is that fine?
Yes, sir.
So this part is simple. Now let us see that how references probably can be used in many occasions in a useful way, instead of just trying to create a clutter of names and messing up the whole thing. So that was not the objective of creating the reference feature. So here consider, so what are the different parameter passing techniques? What are the different parameter passing techniques? When you call a function, what are the different ways you can pass the parameter to a function? Call by, there are 3 call by cases, right? What are those?
So value, address, and reference.
So in C, what kind of parameter passing you have learned in C or you have used in C language?
Value and address.
Just pass by value, pass by address.
Have you used call by reference in C? Anybody of you? Have you used call by reference in C? Call by reference in C? Is that possible? Hello?
It's not there in C.
Yes, so in C there is no notion of, there is no concept of reference. So even though somebody tells that there is a call by reference, but in the context of C language it is not of any use. I mean, it's of no use, call by reference. But in C++, now you know that reference is a particular feature. So sometimes you can pass the reference, call by value and call by address is all known to you. So we'll see that all these 3 cases, how it works. So it's also a very trivial example. So I've written 3 functions, right? So function fn val, fn address, and fn reference. So this is call by value, this is call by address, and this is call by reference, right? So in the first case, so I have used a variable and some other variable z, said assigned initialize it to 10, and before calling I displayed the value of z. So it will be displaying 10, right? Now after that I have called fn val. So this function I have called, and what is called by value? What do I pass here? I just mention the variable name z. So when I pass the variable this z, what happens? Here within this function we have got zz. So we have got zz. So what is zz here? This is also a local argument, a local variable, and this is also a local variable. So how this z gets transferred to this zz? What form?
So the value is copied.
So the value is copied, right? So if you look into the stack segment, so first of all, where this z will be allocated space, this z, which segment this z will be allocated space?
So heap.
Which segment?
So heap segment.
Now don't say like that. Heap segment, how can it be a heap segment after so many classes? Which when space is allocated from the heap segment, in what occasion?
Dynamic allocation.
Yes, is it a dynamic allocation? Am I is it a request for using malloc or new for
No, sir.
space? So why you are telling that it's heap? So don't say like that. I mean, if you have doubts, you can call me, you can ask me and repeatedly interrupt me. But once you are done, I know that it is done. Okay, so and another point is before you come to this class or before you start this class, try to have a revision of the previous lectures if it is required. So I don't know, somebody may require, somebody may not require, because there are other classes also. So this Z will be allocated. So which segment it will be allocated from?
Sir, I think data segment.
Now again there is a mistake. So which type of variables will be
Stack.
allocated? Hmm? Now data segment, what kind of variables they accommodate?
Static variables.
Static and or
Global
global.
variables.
It may be static, it may be global, it may be local static. So no matter what type of static it is, it will be allocated, and also global. So that also is excluded. So what type of variable this is? This is a non-static local to main. So which segment is now remaining?
Stack.
Stack segment, simple. So it's the stack segment. After showing the details of those layout and all this is not expected anyway, so don't stop answering. So you may be right or wrong, doesn't matter. So try to answer, and that is the only way you can recap those things also. So I'm not discouraging you for wrong answers, but I would request you to revise those chapters also, those lectures also. Otherwise the concepts will again remain the same. It's of no use then, because after say one or two classes I'll be talking about static objects, I'll be talking about constant objects, static functions, static methods. So you have learned about static variables, right? So have you heard about static functions? Functions are static, methods are static. Have you heard of it? Hello, heard of it? Those who are Java experts, have you heard of it? A function or a method becomes, there is no function, a method becomes static. You tag it as a static method. Hello. So functions can be static. So once all these things come without the clarity of this memory layout, it will be all messed up. Okay, so this is this is a non-static local function, local variable, so it will be from the stack segment. So let us assume that this is the stack segment, and say Z is here. Okay, so this is Z, and stack grows in this side. It's a open end of the stack, and this is the bottom of the stack, right? So now once this is called, so this is the main function. So within this, the control comes from here to here, right? So control jumps here. So it is now within fn val. So what is going to happen? So Z was 10, right? Z is 10. What is going to happen whenever the control comes out of the main and it enters fn val? What is going to happen? Fn val has got int zz. What type of, so where it will be allocated space? Zz
Stack.
in the stack. So there will be zz here. There will be zz, and what value this zz will contain?
10.
It will be 10. So basically, whatever is contained in z, it will be just handed over. So zz is a space, and this value of z, so this will be copied here, right? So this will be copied. So this is what call by value is. Call by value means this one. So this is basically call by value. The contents of z of the calling function will be copied to the local argument of the called function. Okay, this is what it means. So that's why it is called call by value. So you basically pass the value. So what it is equivalent to? So if I give you something, so I show you the notes. I have got a note. I have got something. So I have got the assignments printed in one of my in one page. You come to me with another page. I just say that copy it down. So that is what call by value means. So you just copy it down, or you get a Xerox of it and you take it out. So you basically return the original copy and you take the Xerox copy of it. So this is what is happening here, right? So ZZ was originally blank. Now whenever there is a call by value, so the contents of Z is copied to ZZ, right?
Yes, sir.
So it's basically giving a Xerox of it. So now if I write ZZ plus, so you took the Xerox copy, I am retaining the original copy. Now you took the Xerox copy, you make all the changes there. So will I see that changes? So this ZZ is basically, if I write here plus plus, so this becomes 11. So it's a Xerox of this original one. So now after returning from this, if I write after call by value, if I write here again, if I write the display the value of Z, so it will be displaying the same Z. So it is just 10, right? Because if you change,
Yes, sir.
and another thing is, whenever the control comes out of it, what is going to happen? Whenever the control comes out of it, so this will be, this is not there at all, right? Whenever the control comes out, whenever it comes back, it pops out, fine, but the Z remains 10. So now again I call fn address, so the call by address, so it goes to this function call, and what is there? So call by address means you are basically passing the address of Z. Address of Z means, so Z's address maybe say 1090. So now to hold the address, you should have a pointer variable here, right? And there is indeed a pointer variable ZZ. So ZZ is now declared as a pointer to integer. So where from it will be allocated space? This ZZ. Where from it will be allocated space?
Stack.
From again the stack segment. So this is ZZ. And what value it will be storing here now? So now you say that I am passing not the value, I am passing the address. So you come to me, and then what I say, okay, I am keeping my assignment copy in my desk, right? So if you want, you can go through it. So that is what I say to the student. So earlier she came, or he came, and I just gave a Xerox copy of it, or he noted down and took it, and he modified it, but that doesn't get reflected. Now I want to get things reflected. So what I ask, that I give you the location where I am storing it, my desk or my say table, wherever. So I give you that clue. So now ZZ, what it contains? 1090. So this is what? This is now called by, this is now called by address, right? This is called by address because you're basically copying the address here. So you're basically passing the address, not the contents. So now here, if I would like to modify, so you know the point, you know my address. So if you write asterisk ZZ whole of plus plus, what is going to happen? Asterisk. So now ZZ is capable of pointing to it. So if I write asterisk ZZ means you are here. If you write plus plus means this will be modified to 11, right?
Yes, sir.
So now whenever the control comes out of it, control again comes out like this, then so what happens? The first thing that is done is, which one gets popped out? This ZZ, which was a local non-static value variable declared within the function fn address. Now the control comes out, the function is no longer active, so it will be popped out. That's the first thing. But you have already made the changes, okay? You have already made the changes in my notes, so it will be retained. So if I now write here, see out this Z, what do I see here? It will be 11, right? Because I made the hello. Yes, I cannot hear you. Anything else? Any doubt? So it will be 11 here, right? Now, so what we can see, the difference between call by value and call by address. Through call by value, if I pass something, if you make any changes to it, it will not be reflected in my own copy, right? Because it is just, I have passed you the value. I have not given you the original
Hello,
content.
sir.
Yes.
Hello, excuse me, sir. So we have class from 5:30, sir.
Okay. Okay, I'll be just completing it within 2 minutes.
Sure, sir.
So will that be okay, or I have to stop it right now? Will that be fine?
So actually
Hello?
we have class from 5:30. It will start soon.
So it's 5:25, I guess. So if I continue for another 2 minutes, is
Yes,
that
sir.
fine?
Yes,
Or
sir.
yes, that is what
Yes,
I'm
sir. For
asking.
2 minutes.
Hmm.
Yes, sir.
So in the first case, in the call by value, there was no change, but in the call by address, if I want, I can make a change. Now, so up to this it is fine. So now if I call function reference, fn ref, what it does? So here I am passing. You see how to pass the reference? I just specify the value, the variable name, and here I denote this one. Okay. So here I denote. You see zz ampersand int. So this is, so zz is now going to be a reference, a new name assigned to the z. So do you think, so if there is a, so this zz is basically a reference, so will there be new allocation that will take place? Will there be any new allocation here? Hello?
No, sir.
So instead of that,
No.
what will happen here is, so there will be no calling, nothing else. Instead of that, this same location will be
Sir,
identified as, yes,
hello, sir. Sir,
yes,
in Y section there is a class from 5:30, sir.
yes, I am done, already done. So Z or ZZ, okay. So the same location is identified either by Z or by ZZ. So if I write here ZZ plus plus, so you are basically making the same change here. So you will be having the effect of that. So from 11 it will be modified to 12. So that's all. Okay. So what you can conclude out of it? Can we achieve the same thing as by passing the reference and also by passing the address? Can we do that? Hello?
Yes, sir.
So that is advantage. And one thing is, if you can notice it, so within that function, when we deal with addresses, you have to write asterisk, then zz whole of plus plus, and when you pass the reference, you can just write zz plus plus. So which one is more easy to read? Definitely passing the reference. So that's why you can achieve the same effect, but you don't have to actually write complex statements using pointers. So that's why passing references is often preferable instead of passing pointers. Okay, so that's the end of the class.